Okay, so today we're going to look at finding rate of change from a table. It's chapter 8, section 4 from your book. Today is October 29th. So you're going to need to watch this, and I'm going to go through the steps for solving so you can take a look at how to find rate of change from your worksheet problem that we talked about today. So questions this might be able to answer: am I going faster, slower? Am I making more money, less money? Or you could use it for comparison. So today in class we talked about a type of movement that you guys did a lab on. I just made up some numbers that were pretty similar to yours. So we have an amount of time and then a distance. So what you're trying to do is figure out rate of change. So essentially we might be comparing how much your speed changed from here to here compared to how much your speed changed from here to here. So in other words, from 100 to 200, is that faster or slower or equal to from 300 to 400? I could even compare 100 to 400 versus 200 to 300. I could compare any 2 points that I want to. It doesn't matter which ones that I choose to do. Okay. When we're solving this, it's going to be a formula that you're going to use every single time. Now, whenever I'm making these, they do have formal labels: time in seconds, distance in meters. Also, whenever I make one of these tables, this is also all of my x values in this column, and then this is all of my y values in this column. So these could all be considered an x. These could all be considered a y. And even though these aren't written in, this is my first x value, my second x value, third and fourth. It's also my first y, second y, third y, and fourth y value. So here's the formula that you would use to solve for rate of change. It's the same every time. It's the change in y divided by the change in x. This looks really complicated. Not too bad at all. Let's say I'm trying to compare, I want to find my rate of change here. So remember, these are x values, these are y values. So I would take 200, my second y value, minus 100, the first y value in my sequence, and divide it by my second x value minus my first x value. So in other words, 100 divided by 32 minus 14. What is that?
40.
18.
18.
Class has not been super helpful here. Yeah, so I could divide 100 by 18. Let's go ahead and pull up the calculator, see what we get when we do that. 100 divided by 18. So my rate of change here is 5.5 repeating meters per second. That's the speed that I am traveling at. If I wanted to find out if I'm going faster or slower, I would do the same thing for 300 and 400. I would plug those numbers into the same formula. I could do it for 200 and 300. I could compare 100 to 400. It doesn't matter at all. Okay? So any 2 numbers I want to compare, it's always the later one minus the earlier one. So I would ask you for a practice problem to solve for the rate of change between 100 and 200 and 300 and 400. And then at which point is the rate of change greater? At this point, you need to pause the video, solve this problem, then click play, and I'll give you the setup for the solution. So click pause. Whenever you're ready, click play. Okay, so hopefully at this point you got your problem set up. I'm not going to take the time to do the actual math, but once you solve, you should be able to tell which one of these is faster, which one is the greater rate of change. So did he run faster from 300 to 400, or did he run faster from 200 to 100? You're going to have to be able to do this in order to solve your homework question for tonight.